on our worksheet, we're given that PO bisects AB and that PO is perpendicular to AB. And then we want to prove that triangle POA is congruent to triangle POB. So I'll write my givens. PO bisects AB, and then PO is perpendicular to AB, and see what we can do with that. So first thing I might want to do if PO bisects AB, that means that O is the midpoint of AB, right? That's the definition of a segment bisector. And then I know that, okay, if O is the midpoint, that would mean AO and OB are the same. And that's definition midpoint. Otherwise, I need to get a couple more things for this to work. I know that I have a common side, so I can go PO is congruent to PO because reflexive. Excuse me. So reflexive. Made a couple errant marks there. Oh well, close enough. And then finally, I actually, because of the perpendicular, should know that 1 and 2 are congruent because of a theorem from some chapters ago that those lines are perpendicular if and only if they form congruent adjacent angles, right? So that was kind of a tough one. You had to reach into that memory bank for it. But when you're doing proofs, you should have those cheat sheets out that I gave you so that you can come up with a lot of these things. But I know that angle 1 and angle 2 are congruent. They're both right angles too, but that actually takes longer to do it that way. So if you want to do the 10-step proof, that's fine. Because remember, perpendicular means that they are right angles. Right angles means that they're both equal to 90. And if they're both equal to 90, you can substitute and say that 1 and 2 are congruent. But that's a lot of steps when I could just say 1 and 2 are congruent because perpendicular, if and only if, form congruent adjacent angles. That's way faster, right? But now that I have all that information, I should be able to do a side angle side to tell you that triangle POA is congruent to triangle POB. And that's that.